All right, the first thing I would remind you is this is problem number 13 on the fourth EOCT review. Guys, take your formula sheet, and on your formula sheet, make sure you can do each of those formulas. A suggestion way for finding out how to do each of those formulas would be like go to Khan Academy and search the formula, and it'll give you a video of him working through the problems. Sal, whatever his name is. But anyway, this is number 13. And the thing that you got to understand about number 13, there's a couple of questions here that are important to the problem that you have to recognize. The first one is that partitions. Okay, the part that says this directed line segment partitions something. It partitions something in a 2-to-3 ratio. So what that means is I have a point here, and based on reading the problem, it says point Q is -9, -6. So I got this point -9, -6, and then over here somewhere else, there's this other point P, and based on this question, it says point P is 2, -1. Okay, to partition this segment, okay, there's a segment here, to partition it into a 3-by-2 ratio. You need to pay attention to this, please. Okay, if I'm going to partition this in a 3-by-2 ratio, that means there are going to be 5 parts to this segment. There's 5 parts to it. So somewhere in here, I got to figure out how or where there's this magical point that breaks this into 3 equal segments over here and 2 equal segments to the right of that. Well, we don't know where this magical point X is. So what I want to do is I want to imagine I've got this point X in there. If you don't know what the coordinates of something are, we can just use XY. Now, here comes the part that's kind of confusing to us. Guys, what you want to figure out is when PX is 3/5 of PQ. Now, you got to understand where this denominator 5 comes from. The denominator 5 comes from adding your numerator and denominator over here. So just add your numerator. If your numerator and denominator were 4/7, then right here this would be an 11. If the numerator and the denominator right here was 1/4, if it said 1/4 right there, this would still be 5. So whatever this number is right there, you get from doing the sum of your ratios. Because what that will do for us, it will break that segment into equal parts. And the result is this will be 3 units, this will be 2 units. A total of 5 units. Now the numerator is just whatever my numerator is over there. Okay, so all of that was done so that you could do this. All that was done is so that you could set up this equation right here, that PX was equal to 3/5 of PQ. Well, if I wanted to find out what PX was, if I wanted to find out what this distance was right here, I would say X minus 2. X minus 2. That would give me the distance. And so I would have a number right there for that. So X minus 2 is equal to 3/5 of the whole thing. So I go 3/5 of the whole thing. Well, the whole thing is 2 minus a -9. What's 2 minus a negative, or -9 minus 2? What's -9 minus 2? -11. Okay, that's how I find my X value. X minus 2 equals 3/5 times -11. Over here, to find my Y value, watch what I do. If I said X minus 2, then I say Y plus 1 equals 3/5 of the length of the whole thing. So if the length of this whole thing was -9 minus 2 is -11, what's -6 minus -1? -6 minus -1. There we go. Now, understand this. Guys, that's what this question is about right here. It's wanting you to have to solve those two equations. That's all this problem is about. You can add all in that confusing stuff. You can add all in the stuff about partitions. You can add what they're wanting to know is that you, as a mathematician, can solve this problem right here. That you can solve x minus 2 equals -33 fifths. That's one problem that you can solve. The other problem that you can solve is y plus 1 equals, well, here the 5's would cancel, and that would leave you with -3. So basically, what this problem is trying to find out that you can do is that you can solve this problem that's got a fraction in it, and can you keep up with all these signs? Again, let me bring to your attention some important situations. The first thing I did was I drew this picture. Guys, draw a picture. Draw that picture right there. I put -9, -6 on the left. I put it, and I labeled it. I put P on the right, and I labeled X, Y in the middle. And then I took my ratio and added my numerator and denominator to get a proportion that I could set up right here for the length of the whole thing. So this ratio gave me 3/5. But again, Coach Hill, that says 3/2. I know it says 3/2, so that means if I'm going to break this up into 3 parts over here and 2 parts over there, then I have to have 5 total partitions. So I have to have 5 sectors right there. So that's why I went 5. Then the 3/5 sets the situation up. So with px, this distance right here, which I get by going x minus 2 and y plus 1, is equal to 3/5 of p cubed. Guys, the distance from -9 to 2 is -9 minus 2. The distance from -6 to -1 is -6 minus -1. So that's 5 units. Guys, if I started at -1 and counted over, if I went -2, -3, -4, -5, -6, look, I get 5 right there. So if I'm at -1 and I want to go to -6, I got to go how many units? I got to go 5. Which direction do I go to get from -1 to -6? Which direction do I go? Use a word. Don't point. Left. Well, look, that's what that says. Left. Now, you walked in the door. When you walked in the door and sat down, I had this problem sitting up there on the board, and you went, I don't like that problem. I don't like that problem because it's got fractions in it. What have I taught you to do to this thing right here? Multiply everything by 5. What's 5 times 2? 5x. 5 times x is 5x. What's 5 times 2? 10. -33. So 5x equals -23. So x equals -23 fifths. Over here, it's just y equals -4. So what we find out is this magical point that we're looking for is at -23 fifths, which would be -4.6 and -4. And that's what you're looking for. And then this distance would be 3 times that distance. That's a lot of work. It's a goofy little problem right there.
That's been good.
Could be. But the whole key to all of it is the word partitions. When you have to break something up into partitions, what I would tell you is realize, take your ratio Add your numerator and denominator to get the number of parts that you need. 3 halves is 5 parts. Just like I said, 4 sevenths would be 11 parts. 1/5. If it was 1/5 right there, you would need 6 parts. Again, where I'm getting that number, that word parts from, is 3 halves. I'm just adding the numerator and denominator. Again, the way you know to look for that is the word in the problem, partitions.